In the last video, we showed how ease allows variables to be assigned not only values but also units, and that the unit consistency of the equations entered in ease is then checked and a warning is issued if the units of the variables don't match up with the equations that they are being used in. The unit conversion database in ease can be used to help convert between units as necessary. This video is a little different than others in that it will not strictly talk about features of the ease software, but it will also present a general suggestion regarding best practices for dealing with units. Every engineer should have his or her own carefully thought out method for dealing with units and unit conversions. Unit conversion errors are one of the most common mistakes that engineers make, and it's clear that the unit checking and the unit conversion features of ease can help avoid these kinds of problems. We have developed a specific procedure for solving engineering problems that makes unit consistency easy to maintain. Inputs to any engineering calculation will inevitably be provided to you in relatively arbitrary units. These inputs then should be converted to the base SI system, so kilograms, meters, second, Kelvin, Newton, etc., because these are a self-consistent set of units. The calculations required to solve the problem can then be carried out using the base SI system, and unit checking will be rigorously applied as we go in order to establish the dimensional consistency of each equation. The results are finally converted from the SI system and presented in whatever units are requested or are most logical, and this process is aided by the use of alternate units. This procedure is convenient because the units of each variable are then going to be self-consistent in the base SI unit system, and it won't be necessary to constantly worry about applying the correct unit conversion to every equation during the development of a model. As a result, if you are working in the base SI unit system and you check the units of your equations, you're actually carrying out a more powerful and complete check on your equations. You're establishing their dimensional as well as their unit consistency. Let's apply this strategy to the problem that we looked at in the last video. This is calculating the mass of a rod that has a diameter of 2 inches, a length of 3 feet, and is made of copper with a density of 8.96 grams per centimeters cubed. The three input parameters that we have here are immediately converted to base SI units using the convert function. So we're going to convert diameter and length to meters, and we'll convert density to kilograms per meters cubed because those are the base SI units for those different quantities. Now we'll enter the equation for volume, and we will set the units for the variable volume V, and we know that the units must be meters cubed because that's the base SI unit for volume. No unit conversions will be necessary. The fact that there are no unit problems detected here means that our equation for volume is dimensionally consistent. Finally, let's add the equation for mass. Mass must be in kilograms because that's the base SI unit for mass. And again, we'll check the units, establishing that our equations are all dimensionally consistent. While it's not necessary that you take this approach, it certainly makes solving systems of engineering equations a lot easier. Note that ease allows an alternate set of units to be specified for each variable, and this makes this process even easier. These secondary units can be specified in the solution window using the same dialog that was used to set the primary units. The value of the variable will now be shown in both the primary and the alternate unit system. In this way, it's easy to tell at a glance what the mass of the rod is in, for example, pounds mass, if that's an easier way to interpret or report this result. It's very important that you understand that the variable's value in these secondary units, they're only shown for the user's benefit, and the value is never used in an actual calculation. The value that ease uses in the calculations is the one with the primary units. You can also set secondary units using the variable palette or the variable information window as we did before for the primary units.